In this video, we shall discuss the second part of metallurgy, namely various steps involved in the extraction of metals. The first step is grinding or crushing of the ores, otherwise known as pulverization. The second step is the dressing or concentration of the ores. Third step is the conversion of ore into oxide. Fourth step is reduction of metal oxide into crude metal, and the final step is purification of metal. So first step is grinding or crushing of ores. This is known as pulverization. Normally ores are found with many impurities with large size, and these ores are first broken into smaller particles by grinding, and this process is called crushing of ores or pulverization. Second step, dressing or concentration of the ores. So as already we had discussed, the ores are associated with impurity particles called gung. So the removal of impurities associated with ores is called dressing or concentration of the ores. Third step is the conversion of ore into oxide. So after removing impurities from the ores, they are converted into metal oxides. And in the fourth step, the metal oxide is reduced into crude metal. In the final step, the crude metal is purified. So thus totally we have 5 steps in metallurgy. Except first step, in the remaining 4 steps we had different methods for the purification of ores and the extraction of metals from their ores. The method to be adopted for the extraction of metal from the ores in the second to fifth steps depends on the chemical as well as physical nature of the ore. Now we shall discuss each step one by one. The ore particles collected from Earth's crust are taken by mining activities, normally are larger in size. They are broken up into smaller particles or powder. This process is called grinding or crushing of ores. This is also known as pulverization. Second step in the extraction of metals from their ores is dressing or concentration of the ores. It is the process of separating the impurities associated with the ores. Several methods are available in the dressing or concentration of the ores. The type of method employed for the dressing or concentration of the ores depends on the nature of the ore, what type of ore it is, then nature of impurities, and also the environmental factors. The various methods employed in the dressing of the ores are hand picking, lubrication or gravity separation, magnetic separation, froth flotation, and leaching. When the impurities present in the ores are quite distinct from the ore, then the ores can be easily separated from the impurities by hands, and this is called hand picking. In levication or gravity separation methods, the ores having high specific gravity are separated from gung particles having low specific gravity. In this method, the ore particles are finely powdered, and the powdered form of washed with rapidly flowing current of water. The lighter particles are washed away by running water. The heavier metallic ore particles settle down. Normally, the metals which occur in the native form The oxide ores and the carbonate ores are concentrated by levication or gravity separation method. Levication or gravity separation can be done using either hydraulic classifier or Wilfley table. In hydraulic classifier, the finely powdered form of ore is dropped into a conical reservoir, and this is called hydraulic classifier. A powerful stream of water is introduced from the bottom of the reservoir. The gung, being lighter, is carried away by water, and the heavier ore particles accumulate at the apex of the cone. The conical shape of the reservoir here helps in reducing the velocity of water and thus prevents the ore particles from being carried away along with the stream of water. The second one is Wilfley table. It is a wooden table having a slanting floor. On this slanting floor, long wooden strips are attached, and these wooden strips are called cleats or rifles. The powdered ore is suspended in a stream of water and delivered at the upper end of the table, which is then given a bumping motion. The heavier ore particles are obstructed by the cleats while the lighter impurities pass over and are carried away by the stream of water. The ore particles which collect behind in the cleats move to one side as a result of motion of the table, and they are collected. So this is Wilfley table. So students who are preparing for the competitive exams should not refer only NCERT textbooks. They should also know some extra points. Next, magnetic separation. In this method, the ores having magnetic properties can be separated from gung, that is impurities. So this method is useful for the separation of ores with magnetic properties from the non-magnetic impurities. For example, wolframite, which is iron manganese tungstate, can be separated from tin stone, stannic oxide. Similarly, the ores such as chromite, pyrolusite, which have magnetic properties, can also be separated from non-magnetic impurities. The electromagnetic separator can be seen in the figure. In this method, the crushed ore is poured on the electromagnetic separator consisting of belt moving over two rollers, one of which is magnetic. The ore having magnetic property is attracted towards the magnet and falls as a heap near the magnetic region, while the non-magnetic impurities fall away from the electromagnetic roller. This method is mostly used for ferromagnetic ores. Next method of concentration of ore is froth flotation. This method is used to concentrate the sulfide ores such as galena zinc blend. This separation method is based on a fact that the gung and ore particles have different degree of wettability with water and oil. In this method, the sulfide ores are wetted by oil to separate from gung particles. Normally, pine oil, eucalyptus oil are used in the froth flotation process. When the ore is wetted with oil-water mixture, air is blown into the mixture, foams or froth is formed. The sulfide ore moves to the surface of froth. In froth flotation, collectors are also added which attach to the sulfide ores and bring them to the surface of froth. Commonly used collectors are ethyl xanthate and potassium ethyl xanthate. In froth flotation method, the compounds which are used to enhance the floating properties of sulfide ores in the froth are called activators. Copper sulfate is a good example for activator. The compounds which suppress or depress the floating property of the sulfide ores in the froth are called depressants. Sodium cyanide and potassium cyanide are examples for depressants. The sulfide ore of lead, galena, when is found with sphalerite, the sulfide ore of zinc, and iron pyrite, sulfide ore of iron, using activators and depressants, the sulfide ores can be separated. When sodium cyanide is added to this mixture after wetting with oil, the iron pyrite and sphalerite go into solution while the galena floats in the froth. After skimming off the galena in the froth, copper sulfate is added and air is bubbled through the water oil mixture containing the two remaining sulfide ores, namely zinc sulfide and iron sulfide. Now the zinc sulfide has enhanced floating property in the froth and it comes with the froth which can be skimmed off. Leaching is a chemical method. Here the ore with the impurities is finely powdered and treated with aqueous solution of suitable reagent. Now the ore is converted into soluble salt or complex, while the impurities, that is gang, remains insoluble. Using suitable chemical method, the metal can be recovered. Some examples can be seen. One example for leaching is cyanide leaching. Here the crushed ore of gold is leached with aerated dilute solution of sodium cyanide. Crushed ore of gold is treated with sodium cyanide solution so that it is converted into cyano complex. Then after filtration and deoxygenation, the leached solution is treated with zinc powder. Now gold is reduced to elemental state and this process is called cementation. So another example of leaching is ammonia leaching. Here the ore containing nickel, copper and cobalt ions are treated with aqueous solution under aqueous solution of ammonia under suitable pressure. Ammonia selectively forms soluble complexes with nickel, copper and cobalt ions. And in the solution, iron 3 oxides or hydroxides and aluminosilicate present as insoluble gung. Then alkali leaching. In this method, the powdered ore of aluminium is treated with NaOH solution at 470 to 520 Kelvin and 35 atmospheric pressure. Here soluble sodium metaaluminate is formed, leaving behind the impurities such as iron oxide and titanium oxide. The hot solution is decanted, cooled, diluted, then is neutralized by passing CO2 gas, where the hydrated aluminum oxide is formed as insoluble compound. This hydrated aluminum oxide is filtered and separated, then heated to get pure alumina. Finally, an example for acid leaching. Here the sulfide ore such as zinc sulfide, lead sulfide can be leached with hot aqueous acid solutions. So an example is zinc sulfate on treating with hot dilute sulfuric acid solution forms soluble zinc sulfate solution and insoluble sulfur. From zinc sulfate, using suitable chemical method, zinc can be extracted or separated. Next, silver extraction. So this is cyanide leaching process. So the equations for extraction of silver by cyanide leaching. So that's all the concentration of ore. In the next class we shall discuss conversion of ore into oxide. If you like this video, you can share with your friends. If you like to provide any useful suggestions, contact us in the email IDs given or through the WhatsApp number 94863 77825.